Welcome to Astronomy Daily, your go-to source for the latest happenings in space and astronomy. I'm Anna.
And I'm Avery. We're excited to bring you more cosmic insights and groundbreaking discoveries from across the universe.
Today, we've got some fascinating stories lined up, covering everything from the latest updates on SpaceX's ambitious Starship program to Blue Origin's plans for a second New Glenn launch heading to Mars.
We'll also dive into the mysterious world of intermediate black holes, which are truly the universe's most elusive objects, and talk about NASA's new initiative to develop orbital transfer vehicles for more efficient space travel.
It's going to be a captivating journey through the cosmos, filled with news that's both professional and easy to understand. So buckle up and get ready for Astronomy Daily.
All right, let's dive into some of the latest news from SpaceX, specifically regarding their colossal Starship rocket. It's been quite a journey for them this year, with a few bumps along the way.
That's right, Avery. SpaceX is gearing up for the 10th full-scale test flight of Starship, and they just received launch approval from the Federal Aviation Administration, which is a big step.
Absolutely. They also completed a final propulsion system test known as a spin prime test earlier this week at their Starbase site in South Texas. After that, the ship was rolled back to a hangar for engine inspections, heat shield touch-ups, and other final preparations.
The target launch date is set for no earlier than next Sunday, August 24th at 6:30 p.m. local Texas time. This flight is crucial as SpaceX aims to move past a challenging period. Last year, 2024, was quite successful for Starship, with 4 flights and significant achievements, including the first catch of a Super Heavy booster back at the launch pad.
But 2025 has been a different story. We've seen 4 disappointing test flights from January through May, and even a ground test explosion in June. These setbacks have pushed back major program milestones, like the recovery and reuse of the upper stage and in-orbit refueling demonstrations, which are both critical for their long-term goals of Mars settlement and supporting NASA's Artemis program.
Let's talk about those setbacks because SpaceX has been quite transparent about the causes. The FAA recently closed its investigation into the most recent in-flight failure in May. The rocket started leaking propellant after reaching space, preventing it from completing its test flight.
The FAA confirmed that the probable root cause was a failure of a fuel component. SpaceX's investigation pinpointed a faulty main fuel tank pressurization diffuser on the forward dome of Starship's primary methane tank. This diffuser failed just a few minutes after launch, leading to a pressure drop and a worsening fuel leak that overwhelmed the attitude control system.
SpaceX actually recreated this diffuser failure on the ground during their investigation and has since redesigned the part to better direct pressurized gas and reduce strain on the structure. The FAA has signed off on these findings, giving them the green light for Flight 10. Now, for the ground explosion on June 18th, this accident destroyed the vehicle Ship 36 and damaged the test site, pushing back the program by another couple of months. SpaceX attributed this to likely damage to a high-pressure nitrogen storage tank inside Starship's payload bay, specifically a composite overwrapped pressure vessel, or COPV.
That's right. The COPV violently ruptured. As corrective actions, SpaceX plans to operate COPVs on upcoming flights at lower pressures, conduct additional inspections for damage, implement more stringent acceptance criteria, and make a hardware change to address the issue. It shows their commitment to learning from every test, whether it's in the air or on the ground.
It's all part of the iterative design process that SpaceX is known for. The previous flights this year, including those in January and March, also faced propulsion failures and lost control, scattering debris. The May flight made it further, completing its engine burn, but then spun out of control, hindering heat shield data collection.
Mastering the heat shield design is absolutely critical, as it's vital for Starship's reusability. For Flight 10, SpaceX will be testing several different ceramic and metallic tile designs to gather crucial data during re-entry. They want this data as soon as possible to inform the design of version 3 or block 3 of Starship, which will be the first to actually fly into orbit.
Beyond the heat shield, there are other ambitious objectives for Flight 10. They plan to deploy spacecraft simulators, mimicking their next generation Starlink internet satellites, an objective that hasn't been met in the last 3 flights.
And for the Super Heavy booster, instead of attempting a catch at the launch pad, which they've done successfully 3 times, this flight will aim for a controlled splashdown in the Gulf of Mexico. This will allow them to experiment with new landing methods, such as controlling the final descent with a different mix of engines, and to avoid issues like the structural failure of the field transfer tube seen in the last booster test, which occurred due to a high angle of attack during descent.
It's clear that SpaceX is using every flight, successful or not, to gather data and refine their designs. They've stated that every lesson learned from both flight and ground testing feeds directly into the next generation of Starship and Super Heavy. They have just 2 more version 2 vehicles before moving to the taller version 3, which will feature improved Raptor engines. It's a true try again approach to rocketry.
Speaking of ambitious endeavors, let's shift our focus to Blue Origin, which is also making significant strides. They are gearing up for the second ever launch of their powerful New Glenn rocket.
That's right, Avery. This launch, dubbed NG-2, is particularly exciting because it will loft NASA's Escapade mission to Mars. Blue Origin is targeting no earlier than September 29th for this liftoff.
The twin Escapade probes, which stand for Escape and Plasma Acceleration and Dynamics Explorers, have actually been waiting for this ride. They were originally slated for New Glenn's maiden launch back in January, but NASA decided not to risk a costly mission delay on a debut flight.
A wise decision, I think. Now that the mission has a target date, Blue Origin has been buzzing on social media, promising some exciting things around New Glenn's pad at Space Launch Complex 36 in Cape Canaveral, Florida.
So, what exactly will Escapade be doing at Mars? It's an interplanetary mission, which is quite ambitious for a relatively new launch vehicle. The twin orbiters will study the magnetosphere around the red planet and analyze how energetic solar wind particles interact with the Martian atmosphere. This kind of data is crucial for understanding Mars's atmospheric loss over time.
Absolutely fascinating. The satellites themselves were built by California-based Rocket Lab, and once in space, their operation will be handed over to the University of California's Space Sciences Laboratory, managing the $80 million mission.
And in addition to this crucial NASA payload, Blue Origin will also carry a secondary payload as part of the NG-2 launch. It's a technology demonstration from satellite communications company Viasat, supporting NASA's Communication Services project for in-space networking.
One more thing to look out for with this launch: Blue Origin will once again attempt to land and recover New Glenn's 188.5-foot-tall first-stage booster on a drone ship in the Atlantic Ocean. These successfully launched a test version of their Blue Ring satellite bus on the first flight earlier this year, but the landing attempt failed. So this will be a big moment for them as they continue to work towards reusability. Now, from the red planet, let's turn our gaze even further out, into one of the universe's most enigmatic phenomena: black holes. Specifically, we're talking about the mysterious intermediate black holes.
That's right, Anna. We know about supermassive black holes at the centers of galaxies, and we understand how smaller stellar mass black holes form from dying stars. But there's always been this missing link, a size range in between, from a few hundred to a few 100,000 times the mass of our sun, that has remained incredibly elusive.
These in-between black holes, often called intermediate black holes or IMBHs, are much harder to find. But a team of astronomers, including Crystal and Karan from The Conversation, along with postdoctoral researcher Anjali Yelekar, have been making significant strides. They're using ripples in space-time known as gravitational waves to spot some of these elusive black holes merging.
It's a bit like being at a baseball game, but you're sitting behind a concrete column, and the crowd is deafening. You can't see or hear the game directly. So, what do? You use a high-quality microphone and a computer algorithm to separate the crowd noise from the distinct thunk of a bat hitting a ball.
And with enough practice, you can start to follow the game, figuring out when the ball is hit, where it goes, and even where the runners are. This is a challenging way to watch a game, but it's similar to how astronomers use specialized observatories like the Laser Interferometer Gravitational Wave Observatory, or LIGO, to listen to the universe.
LIGO is designed to detect the faint gravitational waves produced by two black holes, merging into a single, more massive black hole. By analyzing these waves, scientists can deduce incredible details: where the merger happened, how far away it was, the masses of the parent and resultant black holes, and even the direction in the sky.
Most of the parent black holes observed in these merger events are stellar mass black holes, originating from collapsed stars. But here's where the mass gap comes in. Stars between about 20 to 100 solar masses can form black holes. However, due to complex nuclear physics, really massive stars explode differently and don't leave behind a black hole.
This creates a mass gap, where black holes larger than about 60 solar masses are too big to have been formed directly from a single dying star. These are what the researchers call light intermediate mass black holes, or light IMBHs. They're special because their formation isn't fully understood, and they bridge that critical knowledge gap in how the universe grows and evolves.
In their recent research, the team analyzed 11 black hole merger candidates from LIGO's third observing run. Their analysis showed that 5 of the post-merger black holes were confidently in the light intermediate black hole range.
And here's the kicker. They found that one of the merger events had a parent black hole that was already in the mass gap range, and 2 had black holes above the mass gap. This strongly suggests that there are other, currently unknown ways for the universe to create such massive black holes, possibly through earlier black hole mergers.
It's an exciting finding because it helps us understand how often black holes find each other and merge. As LIGO continues its 4th observing run, astronomers are eager to apply these analytical techniques to new data, hoping to hear even more signals from these elusive, more massive black holes and shed more light on their formation.
That's truly fascinating, Anna. From the fundamental building blocks of the universe, let's now pivot to a more practical aspect of space exploration: how we actually get things where they need to go in the vastness of space.
Absolutely, Avery. NASA has just announced a significant new initiative, asking 6 companies to help the agency move spacecraft between those notoriously difficult to reach orbits. They've awarded a total of $1.4 million to a group that includes some big names like Blue Origin, United Launch Alliance, and Rocket Lab.
This is all about what are called Orbital Transfer Vehicles, or OTVs. These vehicles launch on top of rockets, essentially carrying other spacecraft and then delivering them to very specific, often hard-to-access orbits. It's a game changer because spacecraft usually have limited fuel on board, making it tough for them to change orbits on their own. And rockets, well, most of their fuel is burned just getting off the ground.
Exactly. So OTVs are designed to take a satellite or even a series of satellites away from the main rocket and transport them to another orbit or even further afield into deep space. The initial studies for NASA are due by mid-September, and the agency's long-term goal is to send more missions to the Moon and Mars in a more cost-efficient way.
It's a multi-orbit approach that NASA sees as essential, especially with the increasing pace of commercial space deliveries. Joe Dant, an Orbital Transfer Vehicle Strategic Initiative owner at Kennedy Space Center, stated that these new awards will increase unique science capability and lower the agency's overall mission costs.
And they've got some interesting proposals on the table. For instance, Aeroscience and Technology is partnering with Quantum Space to look at Quantum's Ranger for delivering payloads from low Earth orbit to lunar orbit.
Blue Origin has two studies, one for their Blue Ring platform, which can use hybrid propulsion for orbits ranging from geostationary to cislunar, Mars, and even interplanetary locations. Their second study is for an upper stage of their New Glenn rocket.
Firefly Aerospace is looking at using its Elytra orbital vehicles for lunar orbit operations and cislunar space applications like imaging or payload delivery. Impulse Space has two vehicles, Mira and Helios, designed for payload hosting and deployment, with Helios specifically able to move from low Earth orbit to medium or geostationary orbits or even further.
Rocket Lab is conducting two studies, one for their Neutron rocket and another for an OTV based on their Explorer spacecraft, capable of reaching various orbits including medium Earth orbit, geosynchronous, and even destinations like the Moon, Mars, or asteroids. And United Launch Alliance is studying their Centaur 5 upper stage for rideshare missions to cislunar space.
Really highlights the push towards more efficient, flexible space logistics. With these OTVs, we could see a future where getting to any orbit, no matter how remote, becomes far more achievable and affordable. It really does. From the ambitious next steps for SpaceX's Starship, despite its recent challenges, to Blue Origin's exciting second New Glenn launch carrying NASA's Escapade mission to Mars, and the ongoing quest to understand intermediate black holes using gravitational waves, it's been a packed episode. And of course, the promising developments in orbital transfer vehicles, showing how companies are innovating to make space travel more efficient and accessible. It's clear that the universe continues to offer endless discoveries and technological advancements.
That's all the time we have for today's Astronomy Daily. Thank you for joining us for these cosmic discussions.
We hope you enjoyed diving into the latest space and astronomy news with us. Be sure to tune in next time for more interstellar updates. In the meantime, keep looking up. Bye.